look for the relative maximum and relative minimum of this, and if they are absolute minimum and maximums, we should also indicate them as well. Okay, so we can actually remember the first thing to do is to differentiate, right, so that we can get the critical values of x. We are going to do that, but before we do that, we can expand this bracket. If you don't want to do that, there's also another way you can actually differentiate this, but I wouldn't want to follow that method because it's going to be too cumbersome and it's going to make the work look rough. So let's just go with expanding this. So I expand this expression here. I should have x cubed into, let me expand this one first, 3x. So to expand this, I say 3x all squared should give me 9x squared, because 3 squared is 9 and x squared is x squared, minus 3x times 1 is 3x times 2 is 6x. Okay, then I have negative 1 all squared should give me what? Plus 1, right? Let me go ahead to what I call it now, to open the bracket. So should be x cubed times 9x squared should give us 9x raised to power 5 minus x cubed times 6x should give us 6x raised to power 4. Sorry, negative 6x raised to power 4 plus x cubed. Okay, so we can now go ahead to differentiate. Since we have simplified this, you can see that dy dx equal to 0 to get a critical point. So that means we have to differentiate this and equate it to 0. And when we do that, we remember to take the power here and multiply by the coefficients. 5 times 9 is 45. So we have 45, sorry, 45x raised to power 4 minus 4 times 6 is 24. 4 minus 1 is 3. Plus 3 here becomes 3x squared is equal to 0. All right, so we can, before we do this, we can go ahead to factorize this. Yeah, we can go ahead to factorize this. And if we factorize this, okay, what's the HCF here? 3x squared actually. So if I say 3x squared, open the brackets, use 3x squared to divide all these things here. So 3x squared into 45x raised to power 4 should give me what? Should give me 15x raised to power 2. Yeah. So what I'm simply doing is I'm using 3x squared to divide everything here, okay? Because it's the HCF. Minus 24x cubed into 3x squared should give me 8, because 3 to 24 is 8. X squared into x cubed should be just x. Okay? Plus 3x squared into 3x squared is 1, which is equal to 0. We can go ahead now to factorize this further. We can factorize this further. We have 3x squared. So I'm looking at a quadratic expression inside of this bracket, and to factorize it, okay, remember this kind of problems you have to multiply the first number by the last number, and we have 15x squared. I believe everybody should be conversant with how to factorize quadratic expressions. Right, so the factors of 15 that sums up to negative 8 is negative 3 and negative 5. Yeah, so I'm going to use negative 3 and negative 5. Because say 15x squared, negative 5x minus 3x, the same thing as saying negative 3x minus negative 5, plus 1 is equal to 0. We can see 3x squared into, let's factorize this now by grouping them. HCF of 15x squared and negative 5x is obviously 5x into, so let me make a bigger bracket here, into, if I remove 5x from 15x squared, I should have 3x remaining minus 5x into 5x is 1. HCF here is 1, okay, 1 into the same 3x minus 1 is equal to 0. Now we can factorize this further by saying 3x squared into the HCF here is what? 3x minus 1. So let me make it a big bracket here. And we also have 5x minus 1 over here, which is equal to 0. Okay, so we have that. Okay, no, let me just remove these big brackets. No need for them for now. It's to still give us the same thing, so all right, so this is equal to 0. So we can say that 3x is equal to 0, in which case x will be equal to 0. So if we say 3x is equal to 0, divide both sides by 3, we have 0 over 3, and x is still going to be 0. So you can see that x is equal to 0, or x is equal to -1. Bring here becomes 1 over 3, right? 1 over 3, or x is equal to -1. Bring it here becomes 1 over 5. So these are the critical values of x. So we're going to test it now under the second derivative to know which one gives us relative maximum and relative minimum. All right. So remember that at maximum points, that the square y over the x square is what? Less than 0. And so when we test our critical values, okay, we haven't differentiated for the, we haven't gotten the second derivative, so let me do that. Sorry. Right, now we've gotten our critical values. The next thing to do is to differentiate the second time. Remember, you have to differentiate second time before we test our critical values on the second derivative. So what are we differentiating again? Okay, when we differentiated once, we got this entire function here. So let's differentiate the second time. So remember to take 4 back and multiply 45. If you have 180, if you do that, 4 minus 1 is 3, minus, take 3 back, you have 72x, sorry, 72, not 7x. 72x squared plus, we have 6x. Okay. So these are second derivative. Alright, so we're going to test the critical values of x. We're going to test the critical values of x on the second derivative to know which gives us a maximum or a minimum point. At maximum points, what's happening? Okay, at maximum point, that the square y over the x squared, it should be what? Less than 0. So we're going to test our critical values and see what value of x gives us the maximum point. And remember, we said for the first one, we'll say when x is equal to 0. If we put x at 0 here, watch what happens. Here becomes 180 times 0 cube, which is still 0. 180 times 0 is 0. Minus 72 times 0 is 0, 6 times 0 is 0. So everything here will give us 0. And remember, it must be either greater than or less than 0. So it cannot give us 0. If it gives us 0, our answer will be inconclusive. So we can't tell from x equal to 0 whether it's going to give us a maximum or minimum point. So we say when x is equal to 0, it is inconclusive. Let's just state that there. Inconclusive. So we can now test the other one. So say when x is equal to, the first one was 1 over 3. We just put 1 over 3 here, and we have that 180. So sorry, the square y over the x squared be equal to 180 into 1 over 3 cubed minus 72 into 1 over 3 squared plus 6 into 1 over 3. And this should give us let's see the 60 over 9. This should give us, this first one should give us 60 over 9 if I'm not mistaken. Yeah, 60 over 9 minus this other one should give us 24 over 3 plus this should give us 2, right? Just 2. So let's evaluate this now. So working out this fraction, I should have LCM here is 9. So 9 into 60 minus. Okay, so let me do the line here. Since the LCM is 9. 9 into 9 is 1 into times 60. 63 into 9 is 3 times 24, 72 plus 1 into 9 is 9. 9 times 2 is 18. I have 60 plus 18 should give me 78. 78 minus 72 should give me 4. So I have 4 over 9. Is 4 over 9 less than 0? No, it is greater than 0. So that means this is a minimum point. The minimum point occurs when x is equal to 1 over 3. All right. So we can check for maximum points. We can check for the other one. So let me just wipe this off. Automatically 1 over 5 should give us maximum point, but let's just check. Okay, let's just check. So we can say when x is equal to 1 over 5, we can say that the square y over dx squared should give us 180 into 1 over 5 cubed minus 72 into 1 over 5 squared plus 6 into 1 over 5. All right, so this should give us 180 over 125, if I'm not mistaken, minus this should give us 72 into 25, and this should give us 6 into 5. We know here that the LCM is 125. Okay, I think the LCM is 125. I take 125 into 125 is 180 minus 72 plus not 70, sorry, 25 into 125 should be 5, and 5 times 72 should give us 360 plus 125 should give us 25 times 6, it should be 150. Okay, so let's go say 180 minus 150, which was 330, right? And 330 minus 360 should give us negative 30 over 125. This will give us a negative value, and we know that all negative values are actually less than 0. So that means our maximum point occurs when x is equal to 1 over 5. So we have gotten the critical values that that are found at the maximum and minimum points. So let's go ahead now to find our relative maximum and relative minimum. So let me just quickly wipe this off. Therefore, we can say that the relative maximum at x equal to maximum occurs when x is equal to 1 over 5, right? So equal to 1 over 5, and therefore remember y is equal to x cubed into 3x squared, 3x minus 1 all squared, right? So we'll put the 1 over 5 inside here. That's how we are going to get our relative maximum. So therefore y will now be equal to 1 over 5 all cubed into 3 into 1 over 5 minus 1 all squared. Okay, this becomes 1 over 5 cubed is 1 over 125 into 3 into 1 over 5 is 3 over 5 minus 1 all squared, and this gives us 1 over 125 into 3 over 5 minus 1, which gives us negative 2 over 5 squared, which is equal to 1 over 125 times negative 2 over 5 squared should give us 4 over 25. And this is equal to 4 over 125 times 25. I have 3,125, so we have 3,125. So this is relative maximum. So let's get the relative minimum. So we know that relative minimum at x, remember we got it as at x equal to 1 over 3. So y is equal to 1 over 3 cubed into 3 into 1 over 3 minus 1 squared. 1 over 3 cubed should be 1 over 27 into 3 into 1 over 3 should be 1, right? 3 to 1 over 3 is 1. 1 minus 1 is 0. This is 0 squared, which is equal to 1 over 27 times 0 squared is equal to 0. All right, so this becomes our relative minimum. So that is the answer. Now, this question does not have an absolute extrema. It doesn't have an absolute minimum or absolute maximum, because the range of values for x goes from negative infinity to positive infinity.